What's going on? Welcome to the fourth episode of 10 Minutes with Go. Today, I think I'm writing by myself. I don't know where the rest of the crew is, but it doesn't matter. You and I are going to go for a cruise and talk about Go on our fourth episode. So let's get started. And as usual, I'd like to remind you that this whole series of 10 Minutes of Go is basically an introductory series about the Go programming language. So if you haven't heard of Go, do a quick search of Go or Golang, Lang. You'll find out all you need to know about Go. But here I've teamed up with Women in Linux, and for the past 4 weeks now, we've been talking about Go in a short sessions, trying to get folks interested and get introductory knowledge on Go. So who am I? I am Vladimir Vivien. I'm a software engineer during the day, and I enjoy writing code at night. My main in my main job, I use Go, and back in 2016, I was able to write a book on Go. And you're looking at the picture right here, learning Go programming. And so that's what I've been doing. Every any chance I get to talk about Go, I will talk about Go. So here's the agenda for today. We have a quick review of what we talked about last time. And then today, we're going to talk about source code structure, variables and data type, functions, and we'll look at some code. Now, again, before I move on, I want to remind you that for the last three sessions, we've been looking at fundamentals. And it's very important that we look at fundamentals because whenever you're looking to learn a new language, it's very important to understand the mechanics of the language, what makes, how the language work, because if you're coming from a different language, you already know how to write code. You want to make sure you understand the mechanic of that new language, because that could be source of frustration if you don't know how things work. So that's why we're taking our time to dig into the fundamentals, and then we're basically almost to the top where we're digging ourselves out of the fundamental hole so that we can write some fun code. All right. So quick review from the last episode. Last time we looked at Go project structure, and we looked at what we call library packages. And we looked at two types of packages. One is libraries, where you create code that is shareable within your program or across other programs. We also looked at what we call packages that are called actual programs, where when you write your code, that code is intended to be built as a binary so you can execute it. We also looked at what modules are. When you're starting a new Go project, how do you get started with a module? So today, we're going to start with source code organization. How do you organize your code? How do you, when you're looking at a piece of code on the screen, what are the different parts in that code? And here we're looking at a simple program, and we'll look at that program a little bit later, but we're going to go through it and kind of step by step tell you the different portions of the code, of the source code, so that you can recognize these different portions of the code when you're looking at a Go source code. So first, as we've talked about in the past couple of episodes, we have what we call the package. So in Go, when you start your source file, you declare what package that file is part of. So you do that with a package directive. Next, you place your import block, where this is where you tell the compiler that's going to compile your code what packages that source code will be using. And Go is very particular about that. First of all, you have to put something that you are making a reference to in the code, because if you don't, the compiler will say, hey, you try to import something, but you never use it. And secondly, whatever you import, the compiler has to be able to reach it. So either you pull it down from somewhere, or it's in the case of what we're looking at, it's a package that's part of the standard library, which already comes with Go. Here, we're looking at what we call package scope declarations. These are variables, types, constants, etc. Whenever they go outside of a function, and we'll talk about functions in a minute. Whenever you have a declaration that is at package level, that means any other element in that package has visibility to that particular piece of code. So, for instance, here we're looking at variables that are being declared at a package level. So that means any functions inside that package or any other type inside that package has access to that declaration. And then down here, we have what we call function declaration. So these are at a high level, these are the different parts of your source code. So demo, what we're going to do, we're going to look at that. Let's see, we're going to look at that source code we just talked about. And this is the code right here. And basically, just to go over it real quick, what it's doing is it has a greeting in different languages, several languages at that. And it is stored in a variable, and it is stored as a two-dimension slice. And in Go, we're not going to talk about what a slice is today, but eventually we will get to that. But if you've used JavaScript or Python or Java, you know about arrays, where a slice in Go is an array that can grow and shrink. So here, because we have var outside of a function, that means that declaration block is visible to all section of any other code element in that same package. Here we have a couple of variables here that we declared, and then we have two functions. One is the main function. We talk about what the main function is in the last episode. So if you're interested to know what makes the main function special, take a look at the previous episode. And then we have a custom function that we created. And then basically when you run this program, what it'll do is it basically selects a greeting at random using the ran package from the standard library. So if we run this, I was running it earlier. Yes, you can see that. So if you run this, you see like here it brings Swahili. If you run it again, Klingon, if you speak Klingon, one more time, Spanish. So that's what this simple program does. Now let's go back and continue because, we're trying to do this in 10 minutes, but let's see if we can get there. All right, there you go. Next, we're going to talk about variables and data types. What are variables and how do they store data, basically? So a variable in Go is declared with the var keyword. So here we have another example where we have several variables. And here we see that we have the var keyword that indicates that we have a variable declaration. And then we have the variable name. In this case, it's first name. And followed by the variable type. So in Go, all variables have a type, even as we'll see later, when you don't explicitly provide the type, the Go compiler will either assign a type or figure out what type goes with that piece of variable. But in Go, you always have a data type. And that's why a lot of time you'll hear people refer to Go as being a Go static language. Static type language, sorry. Variables can be declared and initialized at the same time. So let's take a look at how that it's done. So the same, or actually we've modified the program. Now we're looking at how we do initialization at the same time. So you still have the var keyword, you still have the name of the variable, but now we follow that by an initial value. Now, before I keep going, let's go back to this. I want to talk about the initial value, even though when you do not explicitly provide an initial value, Go will make sure that your variable has an initial value, or the Go compiler. But it does that based on the type that you say that the variable is. So for instance, first name, we say it's a string, so it's initialized as an empty string. Oops, sorry. Here, down here, we said age is an int or integer or numeric type. We're not assigning it an initial value, but Go will be like, okay, because you have to have a type and you have to have an initial value, that age variable will be created with a value of 0. So I wanted to point that out. And that concept is called zero value in Go. So here we're doing variable declaration, and we're assigning the type, we're assigning the value at the same time. So that's what I wanted to show. But I also wanted to point out that we no longer specify, or we don't have to specify the type, because the compiler will deduce what the type should be based on the value that you've assigned. So for instance, here we're assigning, for first name, we're assigning a string value, Vladimir. Well, the compiler, when it compiles that code, it'll automatically assign first name as being a type string. So yeah, so inside of a function, there's yet one more way you can declare a variable, and it's called a short variable declaration format. And let's see how that is done. So here, we see that we are, there we go. We're using a new operator instead of the equal as we did earlier outside of the function. We're using what we call the assignment operator. And when we use the assignment operator, it does two things. It declares the variable, and it allows us to assign a value to that variable. And when we do that, Go will automatically figure out what type the variable is. And the other thing to note that is that we no longer have to have, when we use that short format, we no longer have to use the var keyword, and we no longer have to place the type after the variable name. All right, hopefully all of that makes sense. If not, post a question. We'll answer it at the end of the show. All right, Go has several basic data types. So we talked about variables having data assigned to them. So, and we also mentioned that in Go, each each variable must have both a data type and a value. So let's talk about what data types are in Go. So we could start with numeric data types. So whenever you want to store in variables, you want to store values that are of numeric values, you will use a numeric data type. And I've listed pretty much all of them. I don't think I'm missing any one of them. But what they are is integer values, what we call integer values, where you can store both positive and negative values. So we have integer and 8 and 16 and 32 and 64. If you're not familiar with what those are, they're basically the size of how many bytes you need to store the value that you thinking about. So, for instance, if you have a large, like a real large value, you probably want to use int32 or int64. But if you have a small value, like let's say that goes up to only 127, then you would use something like int8. And then int itself is a platform dependent type. It'll default to int32 or int64 depending on the platform, but usually it's int32. And then uint, what we call unsigned integers. They're basically the same as the signed integers, but you can only put positive numbers. And because of that, so if you think of a number line, you have one side you have negative numbers, and on the other side you have positive numbers. if you take that line and you collapse it onto itself, now you can and now you can only represent positive numbers. Then you have double the capacity of what you were able to the number of values you were able to store in that variable. So that's why the unsigned values are. And then you have floats, which lets you store decimal numbers, and then you have bytes for 8-bit value, or yeah, for 8-bit values. And then rune is a special type that Go uses to represent. It's a 16-bit value, and it's used to specifically to store what we call Unicode. So if you look at Go, you'll see that actually what the program we used earlier, where you saw all the non-Latin characters were displayed when we were looking at the message. That's because Go is can display or work with what we call UTF-8 character sets, which allow you to display large or non-Latin based languages. And Go used the rune type to do that. And then we have complex 64 and complex 128, which we will not talk about. Obviously, we have string, which we already see how we can use that. And we also have Boolean type for true false values. Now let's talk about functions. Functions basically are declared with a func keyword. And we've already seen functions before, but now we're going to break down so you can see the different part of the function. So here we have another example where we have two functions. We see that we have the func keyword where we're declaring the function. The first function is main, which we talked about before as being a specialized function for your program. And then the second function is what we call message. And that function is something that we're going to use to do our own logic. And here is just returning a string that says that is prefixed with the word hello. That's what message is doing. So next we see that each function must have a name. So we have a name main for this function and message for the second function. And sometimes a function will take an argument. Main doesn't take any argument, so we don't put anything in here in that set of parentheses, so it's empty. But message take an argument. So within the parentheses, that's where you have your argument list for any parameters that you will provide for the function when you call it. And then we also have a return argument list. So in Go, your function can return not just one parameter, but it can also return multiple parameters when you call that function. And then we also, we have to specify when we write a function that returns a value, we have to use the keyword return or the statement return to tell it what value to return. For instance, in main doesn't return anything, so we don't have a return statement in main. But when you are returning something in your function, you have to put the return keyword. Go functions, interestingly, are also types. They have types and values. So they're not just something that you declare and put executable code in between them, but they're also they have types and have a value. So once something has a type and a value, they can be assigned to variables. And that's exactly what you can do with Go functions. You can use them as data. So here's another example here where we have the same as the previous example, but we've changed it to create a function inside of the message. So now what we have is function value assigned to variable. We have a variable called filter. And now that variable, instead of a plain value, we're going to assign a function as a value to that variable. And we see that now that the function has a body. And also notice that we're using we're using the assignment operator. And because of that, we don't have to put the word var, nor do we have to specify the type. The compiler will deduce that the type of this particular variable is this function right here. So we're looking at the function body, and that function does something very simple. It's called filter. So it's going to filter out the name. So whenever you pass it a name, if it's Vladimir, it's going to add Vladimir Vivien. If it's anything else, it's just going to return it. Now, how do you call that? Well, you call it just like you would call any regular function. And that's what we're doing here. So the variable filter now can be used, because we assign it a function, it can be used as a function name. And that's what we're doing here. We put filter followed by a parameter that we're going to pass to the function. And so hopefully you got a lot out of this. That was close to 10-20 minutes, but that is the end. And let's look at real quick some of the examples. Where are we? There you go. So let's look at the variable. This is no, let's look at, there we go. No, let's look at the function, the last one we're looking at. That was the more interesting one. Okay, so this is the last example that we had on the screen. So if we wanted to run this, let's go in. So if we run it, let's see. Hey, it says, hello, Vladimir. Now, if I changed it and put something else, let's see what it does. Now, one thing I will point out, I was like, well, why doesn't it say Vladimir, hello, Vladimir Vivien? Well, I just noticed that this value that I'm passing to it is lowercase, so it sees it as a different value. But if I change this to uppercase, it should work as intended. And here we are. So hopefully you got something out of this session. I wanted to keep it short because it's a lot of things that we covered today. And also next time, during the next section, we want to start writing some more meaningful code. We'll spend some time, continue to spend some time in the fundamentals, but I'm going to see how we can start looking at things that you can use, more practical things that you can use. All right, so let's see if we have any questions or comments. All right, let's see. See a bunch of hello. Hello. Any questions? Do functions have to be defined outside of the main functions? Yes, that's a good question. Yes, first of all, if you want your functions to be available to the rest of your package, yes, you have to specify it outside of the main function or even outside of any other function. So for instance, let's see if we can still see my screen. For instance, here, where we have a function that it's what we call an anonymous function, because it's not a name function. We didn't give it a specific name. We just assign it to a filter, to a variable. So we call it an anonymous function. But anyway, so this function is only visible to this particular function. So filter, because I'm assigning it a function, I can only call it from within this function. I can't come here and say filter, right? Because it doesn't know what filter is, because filter is embedded inside something else. But message is something that's at a package level. Remember, anything that we put at that level, any code element here is at a package level. So I'm able to see message from anywhere within this package, including other functions. So I'm able to call message from here. So yeah, if I put a, let's do this. If I put a function here, and I put it here. Hang on, let's see. Let's do it as this. Okay, if I do this, I can call it from within main. Okay, so I can call that function from within main, but I cannot see that function from within. Like I can't come here and say hi. All right, and it's telling me that it doesn't know what say hi is. So there's and we didn't specifically talk about the notion of what we call scope, but basically scoping means depending on where you declare something, it limits its visibility. Things that are at package level they have the highest scope, meaning that they can be seen anywhere in the package. But the minute you put it inside a code block, like a function, and we'll see later on, like a different other, other control code blocks, like if or loops, etc. Once you put that code or you put that declaration inside a code block, it's not going to be seen in different part of the code. So hopefully that answered the question. Let's see. What if I wanted standard in? Okay, so let's see what the question is. What if I wanted? So if you wanted, I'm not sure what the question is, but I will take a guess that the question is talking about printing. So the printing that we're doing here, it automatic. Oh, this is standard in. Sorry, I'm thinking of standard out. Yeah, you could do standard in as well. We have functions to do that. Um, when we get to I/O, we'll look at how we do standard in. But of Go has facilities that let you read from standard in or print out to standard out as we're doing. And there's several ways of doing it, and we'll look at how to do that. So one of the thing what I mentioned earlier is that now that we have a good chunk of the fundamentals covered, we're going to start taking a look at more practical things you can use with Go. So things like reading files, how do you read from standard in, or how do you write to files, etc. We're going to start getting into those very soon. There's still a little bit of fundamentals I want to cover, but I think we can combine those and then get into more practical stuff. Um, Another question is, so does string compare automatically? Yes. So the comparison, the compiler will let you do comparison. You can use comparison operators uh, on basically on all the types that Go support. There's some restrictions, but string being one of the easiest one to understand. If you have two string, yes, you can compare them. You can see whether they're equal or not. You can do that without having to write any additional code. Is this Python? I'm not sure what the question is. So somebody asked if this is Python. No, it's not Python. It's Go. Anyway, so I think that's all the questions we have. I'm not seeing anything else. All right, so awesome. So I don't think we have any other questions. So we'll put a stop to it here. I think we did it in looks like right at 30 minutes, which is good. So anyway, so hopefully you got something out of it. And again, this is all fundamentals. It's all to get you ready for what's to come. So if you watching this after it's recorded, thank you for watching. There, 3 previous episodes that walks you through all the fundamentals of how to set up your Go environment and how to start working with your own with your first Go program. And next time we'll start, like I said, we'll start looking at how to write more practical code using the fundamentals that we've been covering. All right. If there are no additional questions, that is it. Thank you very much. See you next time.